Welcome to our channel. Today, we're diving into the most extreme environments in space that scientists are eager to explore. From scorching hot planets to icy moons with hidden oceans, the universe is full of places that challenge our understanding of what conditions can support life, or utterly defy it. We're talking temperatures that would melt lead, pressures that would crush steel, and atmospheres more toxic than a witch's brew. What's remarkable is that even in these seemingly uninhabitable places, scientists believe there's a chance, however slim, that some form of life might exist. So buckle up, because this is going to be an incredible journey through the cosmos. We're going to visit some familiar planets and moons, but from a whole new perspective. Get ready to have your mind blown wide open. Our first stop takes us to a planet that's often called Earth's twin Venus. Now you might be thinking, twin? They don't look anything alike. And you'd be right, at least on the surface, but Venus and Earth share some uncanny similarities in size, mass, and composition. So what went wrong? Why is Venus a scorching hellscape while Earth is teeming with life? Well, it all comes down to its atmosphere. You see, Venus has this incredibly thick atmosphere, about 90 times denser than Earth's. And it's mostly carbon dioxide, a potent greenhouse gas. This CO2 traps heat from the sun, leading to a runaway greenhouse effect. The result? Surface temperatures hot enough to melt lead, around 900 degrees Fahrenheit. To give you some perspective, that's hotter than the self-cleaning cycle on your oven. But it gets even weirder. The atmospheric pressure on Venus is crushing, equivalent to being about 3,000 feet beneath the ocean's surface. Imagine the weight of a small car pressing down on every square inch of your body. That's what it would feel like to stand on Venus. And if the heat and pressure weren't enough, the atmosphere is also choked with sulfuric acid clouds. These clouds rain down sulfuric acid, though it evaporates before it hits the ground because of the extreme heat. Talk about a bad day, right? Now, you might think that with all these extreme conditions, Venus would be a dead planet, but scientists are fascinated by the possibility of life existing in the Venusian atmosphere. High above the scorching surface, where temperatures and pressures are more Earth-like, there could be microscopic life forms thriving in the acidic clouds. It sounds crazy, I know, but hey, life finds a way, right? Next, we're traveling out to Jupiter, the largest planet in our solar system, to visit one of its most intriguing moons, Europa. Now, Europa might look like a giant snowball from a distance, but don't let that fool you. Beneath its icy shell lies a deep, salty ocean that scientists believe could hold more water than all the oceans on Earth combined. Think about that for a second. More water than Earth, on a moon that's smaller than our own moon. It's mind-boggling. But here's what makes Europa truly special. This subsurface ocean is thought to be in contact with a rocky seafloor and may have hydrothermal vents, similar to those found on Earth. On Earth, these vents spew out heat and chemicals from deep within the planet, providing energy for thriving ecosystems that exist in total darkness. These ecosystems are completely independent of sunlight, and they've changed our understanding of where life can exist. So, if hydrothermal vents can support life in the depths of our oceans, could they be doing the same on Europa? That's the billion-dollar question, and it's one that has scientists incredibly excited. Imagine finding alien life not on another planet, but on an icy moon orbiting Jupiter. But exploring Europa's ocean won't be easy. The ice shell is estimated to be between 10 and 15 miles thick, presenting a significant challenge for any robotic probe trying to reach the water below. Still, NASA and other space agencies are developing ambitious missions to do just that. They're talking about ice-penetrating robots, underwater drones, even the possibility of deploying a lander that could melt its way through the ice. Now let's journey even farther out into our solar system, to Saturn, the ringed jewel of our cosmic neighborhood. Saturn has over 80 moons, but today we're focusing on one in particular, Titan. Titan is unique in our solar system because it's the only moon known to have a dense atmosphere, an atmosphere so thick that it actually hides its surface from view. Imagine a world perpetually shrouded in a hazy orange glow. That's Titan, and this atmosphere isn't just any atmosphere. It's composed primarily of nitrogen, just like Earth's, but with a twist. Instead of water, Titan has methane. We're talking methane rain, methane rivers, methane lakes, even methane-spewing volcanoes. It's like something out of a science fiction novel, a world where liquid methane plays the role of water on Earth. But here's where it gets really interesting. Scientists believe that Titan's unique chemistry, combined with its internal heat source, could create the conditions necessary for some form of life to exist. This life wouldn't be like anything we've ever seen before. forget about DNA and water as we know it. We're talking about the possibility of life forms that thrive in liquid methane, using it as a solvent instead of water. It's a concept so mind-blowing that it's hard to even wrap our heads around. To explore this alien world, NASA and the European Space Agency teamed up to send the Cassini-Huygens mission to Saturn. The Huygens probe, which landed on Titan in 2005, provided us with our first glimpse of this enigmatic moon's surface. And what a sight it was! Vast plains, towering dunes, and what appeared to be riverbeds carved by flowing liquid methane. The images were breathtaking and only deepened the mystery surrounding Titan. Is there life out there, swimming in methane lakes or burrowing beneath the surface? It's a question that future missions like NASA's Dragonfly will hopefully answer. Now, we can't talk about extreme environments without mentioning our next-door neighbor, Mars. It's the planet that's captured our imaginations for centuries. A world of rusty red dust, towering volcanoes and canyons so grand, they make the Grand Canyon look like a ditch. Mars is cold, dry, and desolate, with an average temperature of about -80 degrees Fahrenheit. That's colder than the coldest temperature ever recorded on Earth. Its atmosphere is thin, about 1% the density of Earth's, and it's constantly bombarded by harmful radiation from the sun. But here's the thing. Mars wasn't always like this. Billions of years ago, it's believed to have been a much warmer and wetter planet, with rivers, lakes, and maybe even oceans. So what happened? Well, Mars lost its magnetic field, which acted like a protective shield, deflecting solar wind and preventing its atmosphere from being stripped away. Without this magnetic field, Mars's atmosphere was slowly blown away by the solar wind, and its water either evaporated into space or froze beneath the surface. But even though Mars is a harsh mistress, it holds clues to its past habitability, and the possibility of life, either extinct or perhaps even still clinging to existence somewhere beneath its surface. That's why Mars has become the ultimate destination for our robotic explorers. From rovers like Curiosity and Perseverance, which are currently roaming the Martian surface, to orbiters like Mars Reconnaissance Orbiter and MAVEN, which are studying its atmosphere, we're piecing together the puzzle of Mars's past. And it's not just about robots. Space agencies around the world are actively developing plans for human missions to Mars, with the goal of one day establishing a permanent human presence on the red planet. For our final stop, we're taking a bit of a detour, a fiery, awe-inspiring detour, to the very heart of our solar system, the Sun. Now you might think I'm crazy for even suggesting that we could explore the Sun. After all, it's a giant ball of hot gas, a nuclear furnace that's constantly spewing out radiation and charged particles. And you'd be right, at least about the landing on the Sun part, but there's one region of the Sun that has scientists particularly intrigued. Its corona. The corona is the outermost layer of the Sun's atmosphere, and it's a place of intense heat and mystery. Here's the weird part. The corona is actually much hotter than the Sun's surface. We're talking millions of degrees Fahrenheit compared to a mere 10,000 degrees Fahrenheit on the surface. It's like a pot of water boiling so violently that the steam is hotter than the stovetop. Scientists are still trying to figure out exactly how the corona gets so hot. They have theories about magnetic fields and sound waves, but it's one of the biggest unsolved mysteries in solar physics. And it's not just an academic curiosity. The Sun's corona is the source of the solar wind, a stream of charged particles that constantly flows outward, impacting planets and other objects in the solar system. These solar storms can disrupt satellites, knock out power grids, and even pose a radiation risk to astronauts. So, understanding the corona is crucial for protecting our technology and, one day, our astronauts as we venture farther out into space. To study this enigmatic region, NASA launched the Parker Solar Probe, a spacecraft on a daring mission to touch the Sun. The Parker Solar Probe is flying closer to the Sun than any spacecraft before it, braving intense heat and radiation to unlock the secrets of the corona. It's a mission of extremes, pushing the boundaries of engineering and our understanding of the star that gives us life. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating space content. Let us know in the comments which extreme environment you'd like to learn more about. From the scorching hellscape of Venus to the icy plains of Europa, the universe is full of mind-blowing places that challenge our understanding of what's possible. And the best part is, we're just getting started. With each new mission, each new discovery, we're peeling back another layer of the cosmic onion, revealing a universe more wondrous and awe-inspiring than we could have ever imagined. So keep looking up, keep asking questions, and never stop exploring.